Hello everyone, my name is Kaixu, and I behalf of the OpenGMS, and I'm from Liaoning Normal University and Nanjing Normal University, and I would like to share the standards for sharing, reusing, and integrating geographic analysis models. And we all know the geographic analysis models is a main expression form of geographic processes and geographic laws. And it's also an important component of GIS. And geographic simulation is an important means of geographical research of the new area and also an important direction for the development of GIS. For different research fields, specific research objects and regions, scholars related to Earth sciences have carried out relatively extensive geographic modeling and simulation works, constructing a large number of geographic analysis models, as well as a GIS software with relevant modules of spatial analysis and geostatic analysis. And in the new IT era and with the development of open science, geographic simulation is an important research method for exploring surface processes and human-land relationships, and is also a core functional component of GIS. The development of technology, innovation, and the concept of open science in the new IT area has promoted the rapid development of geographic simulation in cyberspace. The service-oriented transformation of geographic simulation resources has become a key breakthrough for the development of the new generation of geographic analysis GIS. And the UNESCO called for the conclusion for community arguments such as metadata standards within the regional or global research community to promote the realization of open science. And the Open Modeling Foundation is committed to promote the formulation of metadata standards for model access, documentation, interoperability, and reuse, and has held multiple meetings worldwide to discuss model standards. But there is no consensus on the content, structure, and form of geographic analysis models. And the background of the main trend on the development of size, the sharing, combination, use, and development of geographic analysis models had become several restricted, and it's urgent to formulate a series of standards for models. So, with our team named OpenGMS, is led by Professor Min Chen and Professor Lu Guonian from Nanjing Normal University, and our team has developed a platform named OpenGMS, and the platform is you can explore and sharing resource about geographic models and simulations on the platform. And our platform have collects more than 4,000 model items, and our 3,000 model services and over 20,000 data items and so on. And based on the platform, we have proposed and designed several standards for sharing, reusing, and integrating geographic analysis models, like two association standards named Geographic Analysis Model Metadata and the Geographic Analysis Model Service API. And these two standards are published by China Association for Geospatial Industry and Sciences. And another standard is a specification of Service Integration API for geographic information analysis models, but this standard is under drafting. And let's have a look at the geographic analysis models metadata. First of all, we collect and organize the model standards applicable to different fields from paper and model repository, like Ecobase, which is applied in the field ecology and so on. And after sorting out the existing metadata description, specification of the geographic analysis models, we further confirmed that the types of model feature recorded by this metadata are different and the details vary. And different disciplinary fields have not reached the consensus on the content of model metadata specification, and no standards have been formed yet. And in order to unify the model combination, we aggregate and integrated the above-mentioned various types of metadata and initially obtained an original model and metadata framework that is applicable to the relevant fields of geography. And the original model metadata framework contains over 300 metadata properties. And after classifying and sorting out the content of the original metadata framework, we classify the metadata attributes in the three categories, including overview, design, and usage. And at the same time, we found the following problems. The first problem is the metadata content is too complex and difficult to use. And the second problem is there are too many domain-specific terms which are not suitable for the exchange of model knowledge among various domains. And in response to the above problems, we have carried out the deduplication and the simplification of the framework and merged multiple expressions of the same attribute and removed most of the specified terms. And we finally formed the standard, and the standard's technical scopes is specific the content of the metadata of geographic analysis model. This is including the developer of geographic analysis model, distribution identification, project identification, revision, classification, scopes of application, model performance, and so on, and other regarding to the characteristics. The standards provide a comprehensive description of geographic analysis models and is applicable to the field of computing, sharing, integration, and service of geographic analysis models. And the main design concept of our standards is the content of metadata is controllable in detail and is divided into mandatory, required, and optional content. And we also provide recommended and customizable metadata templates that enable users to combine model and data as needed. And users can fill in the same parts respectively during the model design, development, and completion stages. Among them, the metadata in the model design stage can also be used to guide the model development. And the standard is machine readable, and it provides support for the service-oriented sharing and reuse of models. And the metadata hierarchy is the metadata is divided into three layers, including metadata subsets, metadata entities, and metadata elements. The metadata elements are the most fundamental information units of your metadata. A metadata entity is a collection of metadata elements used to describe the same object. And metadata subset is a collection of metadata elements, metadata entities, and metadata subsets used to describe the same object. And the condition of the standards is described that indicates whether a metadata entity or element always occur or sometimes occur. The descriptor including M means mandatory, and C means mandatory under certain conditions, and O means optional. And the content of the standards is to find, facilitate users with different needs to quickly retrieve and locate the required metadata attributes. The standard summarizes the metadata attributes in according with the basic information, design, and usage of the geographic analysis model to obtain the metadata of the geographic analysis models. And we also use the UML to describe the part of the details of our standards. And this is the UML of basic information, and this is the UML of design, and this is metadata UML of usage. And the language in the picture is Chinese, and we in the future we would like to promote the standard to an international standard. And next, we let's have a look at the Geographic Analysis Model Service API. And the current standards related to Geographic Information Service API are mainly designed for geographic dataset and are difficult to be directly applied to the description in the API in the network. And we have collected the Geographic Information Service API, including 6 parts, like human-computer interaction, information management, workflow task management, information process, and communication and system management. And in order to construct an API framework suitable for geographic analysis model services, based on the Geographic Information Service API, we summarize the common characteristics of geographic analysis model services and object 6 types of geographic analysis model service API. The service API classification including management, description, deployment, integration, data, and invocation API. And our standards technical scopes is in response to the service-oriented application requirement of geographic analysis models. The standards contains API for the service-oriented description, deployment, execution, release, and the invocation method of geographic analysis models. The designed API contents includes the description of model service capabilities based on the different programming languages and operation forms, the execution of model service functions, and encapsulation, deployment, publication, management, and invocation of model service, and so on. The standards provide a comprehensive description of the service API of geographic analysis models and is applicable to the fields of computing, sharing, integration, and service of geographic analysis models. And this is the standards classification. And the standards stipulates the service API of geographic analysis models are mainly divided into 6 categories, namely model management API, model description API, model deployment API, and integration and data and invocation API. And the management API is used to management model services and operation records, such as model service list API and operation record list API, and so on. And the description API is used to describe the attribute characteristics of model service, such as query attribute API, and so on. And deployment API is used for instantiating and deploying model services, such as deployment package, integrated detection API, run environment detection API, and so on. And the integration API is used to integrate different types of model services, such as creating integrated working API, workflow API, and so on. And data API is used to operate on the input and output data of the model service, such as input event API and so on. And the last is invocation API. It's used to access and utilize model services, such as online service detector API and running state API and so on. And finally, standard is a specification of service integration API for geographic information analysis models. And due to the inconsistent technical standards and the implementation method among different systems and platforms, problems such as information isolation islands and data incompatibility occurs frequently. Serious restricting and the sharing and application of geographic information analysis models in order to enhance the interoperability and expansibility among geographic information analysis model services, promoting resource sharing and improve the absence and development and usage. It's necessary to form a unified API specification for the integration of geographic information analysis models. This specification aims to provide a standard API definition for the integration and application of geographic information analysis models, promote seamless connection and resource sharing among different services, thereby supporting more efficient decision-making and facilitating the resolution of more complex geographic problems. And we initially classified the APIs used in the model integration process into 5 categories, including model service meta API, model service parameter API, and integration API, and the data operation API, and the model service integration flow operational API. And the standards is under drafting. And that's all. Thank you.
Thank you very much. I was really interested in your metadata model. It looked very, very complex. Does anybody have any questions? The one question I would have is, when you were driving this model, did you do any comparison with any international metadata standards?
We're trying to develop this standard to an international standard, but not yet.
Not yet. Okay, so it's ongoing work.
Okay.
Right. Because it's been mentioned quite a lot today. 115, it's a conceptual metadata model that covers everything. So it's just been interest of mine. If you do that comparison, I think we probably find quite a lot of common aspects between the two.